Basic trigonometry. This is going to be lesson 3. This is on the law of sines. Now, the law of sines says that the sine of angle A over its opposite A equals the sine of angle B over its opposite B, which also equals the sine of angle C over its opposite C. So let's draw this out in a triangle. We'll just make it like, we'll make it like this. Let's move that down. Make it right here. We'll make this A, B, and C. What this is saying is the sine of angle A, so this is angle A, over its opposite. So this lowercase a is going to be its opposite. So the opposite of angle A is right here. And then the same with opposite of angle B and opposite of angle C. So what does this mean? Well, what it's saying is that the sine of an angle over its opposite is the same as the sine of another angle over its opposite. So let's do this with an actual numbers example. Let's say that this is going to be 39. This is going to be x. We'll make this 19. And this right here will be 17. So, using the law of sines, I know that the sine of this angle, the sine of an angle over its opposite, is the same as the sine of another angle over its opposite. So let's write that out. So the sine of 39 over 19 is the same as the sine of x over 17. Now, in order to solve this further, we have to do something called cross multiplying, which is where you take, almost like a little band-aid, you take the diagonals, like a little band-aid, and you multiply each strip. What I mean by that is you're going to multiply 19 times sine of x and 17 times sine of 39. So write that out. So 19 sine of x equals 17 sine of 39. Now we need to simplify this further. In order to isolate the variable, we need to divide this side by 19 and this side by 19 as well, which means that sine of x equals 17 sine 39 over 19. Now, in order to remove the sine, if you saw the last video on SOHCAHTOA and trigonometry, you would know that you have to use something called the arc sine. So I'm going to show you what the arc sine is, but basically the arc sine just cancels out the sine, the regular sine. So we're going to times this by the arc sine, and what you do to one side, you have to do to the other. So we're going to take the arc sine of this side as well. So now I know that x equals 17 sine of 39 over 19 arc sine. Now, if you put that into a calculator, let me do that really quickly. So if I type into my calculator 17 times the sine of 39 over 19 arc sine, I should get 34.3 rounding to the nearest tenth. So now I know that this x angle is, what did I say? 34.3. And then you can go on to solve the rest of the triangle, which we're going to do in this next example. We're going to take one more example. We're going to make a pretty equal looking triangle here. Maybe not fully equal. Yeah, not very equal looking. But we're going to say that this is 63. This is our unknown angle. This is an unknown angle. This is going to be an unknown angle. This is going to be another unknown angle, and we know that this is 4 and this is 6. So, how do we solve for each variable? Well, let's start with x, because I know by law of sines that the sine of an angle over its opposite is the same as the sine of another angle over its opposite. So let's do that again. The sine of 63 over 6 equals the sine of x over 4. Now if we cross multiply like shown before, multiply each bandage, 6 sine of x equals 4 sine of 63. Now, start breaking it down. Sine of x equals 4 sine of 63 over 6. And then we take the arc sine of each. I know that x equals 4 sine 63 over 6 arc sine. So, if you put that in a calculator, give me 1 second, 4 times the sine of 63 divided by 6. 4 times the sine of 63 divided by 6, arc sine equals 36.4, rounding to the nearest tenth. So let's replace our x variable right here. It's going to be 36.4. So now that we know this, I also know that the interior angles, so all 3 angles of the triangle, will always add up to 180 degrees. Every triangle is like that. So let's do that. Y plus our 2 angles, 63 and 36.4, equals 180. So now I can say that y can't I draw here? Y plus, I'm sorry, what is that? Plus our 2 angles equals like 99.4. Oh, sorry. Plus this equals 180 minus this from both sides, and y equals 80.6. So now I know that this angle right here is 80.6. So we can go right back to doing the law of sines. So I'm taking this angle again. The sine of this angle over its opposite will be the same as the sine of this angle over its opposite, z. So the sine of 63 over 6 equals the sine of 80.6. What am I doing? Sine of 80.6 over z. So we cross multiply here. So z sine of 63 equals 6 sine of 80.6. Now we're going to isolate the variable z, so that z equals 6 sine of 80.6 over sine of 63. Now you plug that into a calculator. Give me 1 moment once again. 6 times the sine of 80.6 divided by the sine of 63. It should equal about 6.6, rounding to the nearest tenth. Let me circle this for earlier. So this should equal about 6.6. And now I have solved my entire triangle, all of the angles and all of the sides using law of sines.